Hello, hello, welcome back. This will be your Quiz 9 Solutions video. And here we go. The first two questions are just basic, like, definition questions. In an addition reaction, an alkene, what does the pi bond act as? That is the nucleophile, because that is the electron-rich area. Next, identify the compound that is not produced industrial from an alkene. The only one that's not in the list of things I told you about is methanol. Next, the decrease in entropy, the delta S value is negative, is observed for alkene addition reactions that result from what here? It would be two molecules are acting to form a single molecule, right? Because then we are uh, decreasing disorder, right? We're getting more ordered when we go from two things to one thing. So the answer there is E. Number four, the rule that correctly predicts the regiochemistry for most ionic additions to alkenes is named after who? That's Markovnikov. Remember, that's Markovnikov addition and Markovnikov, anti-Markovnikov, right? Where the substitution either happens at the most substituted carbon or the least substituted carbon, depending on Markovnikov or anti-Markovnikov. So B for 4. Vladimir Markovnikov. Excuse me. Which of the following structure depicts the most likely carbocation intermediate formed in the hydrohalogenation of this reaction shown? The only one here that is a tertiary carbocation is this one here, so that's structure 2. So that's going to be it. What is the expected product for the hydrohalogenation for the following alkene with HBr? So if you remember, it's in the name, hydrohalogenation, which means that you're going to add a halogen and you're going to add a hydrogen, right? The only one here where you've added a hydrogen and the only one here where you've added a hydrogen and a halogen, right, is V. Structure 5, E. Okay, sorry. Because, yeah, there's no halogen there at all. There's no halogen there. There's no halogen there. And there's two halogens there. How'd that happen? So the structure is definitely... the correct one is structure E, or 5. Next, we have here what is the major product for this reaction here? We have HBr, right? So that's another hydrohalogenation, but it's in the presence of some peroxide. What do we get when we have that? We get an anti-Markovnikov right? We get an anti-Markovnikov addition. The only one here that has an anti-Markovnikov addition is structure here. Structure 1. Okay, structure 1. If it were Markovnikov addition, that means there's no peroxide, and the answer would have been D, right? Because that would have been a Markovnikov addition right there. But since there is peroxide here, right? Since there is peroxide here, which I'll erase my line, it's definitely anti-Markovnikov, and so the answer is structure 1, or A. The next question is basically the same thing. Which molecule below arises from the given alkene undergoing anti-Markovnikov addition of hydrohalogenation of HBr? All right. The only one here that has anti-Markovnikov addition is this one right here, right? The one with the least substituted carbon, right? The one with the least substituted carbon gets the bromine. If it had been a regular Markovnikov addition, right? Just a regular Markovnikov addition, it would have been this one. But since it's a anti-Markovnikov addition, it's definitely structure 3. Okay, so predict the major product of this reaction. This is another hydrohalogenation, right? With a hydrogen and an iodine. This time there's no peroxide available, so that's going to be a normal old run-of-the-mill Markovnikov addition. So the halogen is going to be added to the carbon with the most substitution, which is going to be structure 1. And then last but not least, we have the What is the major product of the following here? So we have the mercuration, oxymercuration. Wait, mercuration? Deoxymercuration? That reaction, the one that deals with mercury. And you get that mercury bridge from one carbon to the next, right? The one I can never say, mercurinium ion, right? And the purpose of that was so that you don't get any carbocation rearrangements, right? So you get the structure you want. Okay, so the answer to this one then would be, the only one that actually makes sense would be this one here. Right here. Right, structure 4. Because the proton you're going to be, the proton that you're going to be, or sorry, not the proton that you're going to be, but the double bond, sorry, there it goes, the pi bond will attach itself to the mercury, giving you the mercurinium ion. I don't know why I said mercurinium and then I've put in a BR. That is so weird. Hg. Let me draw that again. There we go. Right. And so your carbocation will be right here. Right. Your carbocation will be right there, and then your water can go over and do a nucleophilic attack on that carbocation there. So that's why the structure, the correct one is structure 4 or D. All right, that's it for this quiz, and I'll see you in the next lecture. I believe our next lecture is radical reactions. Radical.